Hello again everyone. In our last video, we manually compute for the critical path of this project network. We found out that the critical activities for this project are the following: B, C, D, F, and H. Now we're going to make a program in Python 3 to automate this task. Okay, so basically we will get this from column A to column D, this data, and then we will make a program in Python to solve for the early start, early finish, latest start, latest finish, and slack, and tell us if it's critical or not. So now we're going to open our text editor. First, we're going to import some libraries like the OS, import OS. This will clear the screen in our console. The regular expression for scanning the data, and the pandas data frame. Now we're going to create an object. So the idea is that in each individual activities there will be an object, and we will name that object as task. So for example, activity A, this is one object. Okay, activity B will be one object, activity C will be another object, and so on and so forth. So now this task, we initialize each task to get the description of the task, the activity, the predecessors, and the days. These four information are needed to compute for our computation. Actually, the description is not required, but we need to put it in so that the final output will include the description. Okay, as soon as this data has been obtained, we will put it in a variable, class variable, to self the description, the activity, the predecessors, and the days. And then we create some additional variables as early start, early finish, successors as a list, the latest start, the latest finish, the slack, and the critical. So the early start should be in integer, early finish should be integer, successors are list, and these two are integer as well as slack, and the critical is a string. Now in this class we also have one function. This function will compute for the slack. Given the variable of the object latest finish, we subtract it with the variable of earliest finish, then we put them inside the variable self the slack. And the self slack, also the slack will provide us with a indication. We put it in a variable critical. If it's critical, we indicate yes. If the activity is not critical, we indicate it no. Okay, so we initialize the variable with these four variables, and we create some additional variables. Then we create a function to determine. Next, we're going to create the functions. Okay, the first function is read data. In this function, we need to get the data. On this case, it's data.xlsx. Okay, we can provide what data file you need, which contains this data 1, 2, 3, 4. Okay, so you put it in there, and then we read it using pandas. We state the command pd.read.excel, and we input the data name, the file name, and the sheet name. In this case, the sheet name is sheet 1. So, and then this function will return the data frame. Okay, next we define another function, which is create task. This function will create individual tasks and put it in a list. So we make a list, and then we iterate on that list based on the length of my data. Okay, my data, and then we append the description and the activity and the predecessors and the days of my data to the task object. What this does is that we create an object. Okay, a list of objects, list of tasks. So this is a list of tasks wherein each task has has obtained the data from the data frame. Okay, so this sheet has a data frame, and this object will obtain some data in the data frame, okay, and put it in a object class. Okay, then we return the task object. So this is already the task object is already a list containing those tasks which has been created in this function. Okay, if you remember, in order to create a task object here, this is a task object, we need to have 4 variables: the description, the activity, the predecessors, and the days. So again, on top, here it is: a description, the activity, the predecessors, and the days. Okay, afterwards, if we're going to have already the task, we now are going to go with creating the forward pass. So the forward pass is a function again here to compute for the early start and the early finish. So this is the forward pass. Okay, and if you want to have a recap on how the forward pass has been computed, please please view the part 1 of this video. Okay, and the link is in the description below. So that's it. So in forward pass, as a recap, first, the rule 1, the early start of an activity with no predecessor is 0. Okay, for in this case, if there is no predecessor, the early start is 0. Okay, and rule number 2, the early start of an activity with predecessors is the maximum early finish of its predecessors. Okay, for example, in activity C, the early start of activity C is the maximum early finish of activity A and B. In this case, the early finish of A is 6 and of B is 9, and the maximum of the two is 9. That's why the early start of C is 9. Okay, so now, in order to implement these 3 rules, we need to create a loop. So we need to iterate from the different tasks from task A to H in task object list. Okay, then we need to check if the task that predecessor is a string, because the task of the predecessor, there's a comma there. Okay, and here this is a string, but these two are not strings, so we need to check if these are strings or not. Okay, then if we found out that the tasks that predecessors are strings, then we need to make it in uppercase. If it's not in uppercase, next word and next one, we need to make a list. Okay, the objective of this is to store the earliest finish of all of the task predecessors. Okay, the objective is to store all the tasks of predecessors. Okay, then we need to get the maximum latest finish. Okay, so for J in task, we'll create again a loop for J in task at predecessors, so we iterate on each task, and for T in task object, so in the individual predecessors. So we are now looking at this task at predecessors. We are now iterating in this. So for each task in its task predecessor, for example, in this predecessor we have A, next is B. Okay, A, we need to check if this, what activity is this. Okay, so if activity C has task predecessors A and B, we go now to A and check the early finish. Okay, we go now to B and check the early finish, and then we compare these two. So that is what is this now. So we need now to, for T in task object, so this is now we access again the task in the task object list. If T, the activity, is equal to J, okay, so it means that if the activity is inside J here, the predecessors, okay, now we need to append the earliest finish of this activity in EF list. So what it means to say is if A is in here, okay, we need to append the earliest finish, this one, into the list. In this case, we're going to append this and this. Okay, so we're going to append them there, and afterwards we select the one which is maximum. So here we select the one which are maximum. Okay, so we select it here, and okay, task at early start is the maximum. So we already indicate the early start. So we already computed the early start for a stack of a task. So it is the maximum early finish of the two predecessors. Okay, afterwards, when we already put here the data, we delete the file, we delete the list again, and we go back again for another task. Okay, and so on and so forth. But if the task is not a string, again, if it is not a string, if the predecessor task is not a string, here, they're both of them. Okay, if they are not string, okay, if the task predecessor is not string, okay, then the task at early start is 0. Okay, if there's no string here, nothing, no task early, so automatically the early start is 0. But again, in this case, there is predecessor, so the early start is not 0, but the maximum of the predecessor's early finish. Okay, so that is how we're going to compute for the forward pass. So now we need go now to compute for the task that early finish for both of the scenario. Okay, that is task that early start, because we already know the early start, this one, in this what you call this, in this loop, we already know the early start. Okay, and we can now compute for the early finish by adding the early start and the task days. Okay, because for each task, make a loop here, we put in the file, we put in the data, and then we compute for the earliest finish. So after we compute the early start in this loop, we can now compute the earliest finish. Okay, because the days are given already. Okay, the task set days are already given when we initiate the instance of a class object. Okay, in this case, this task object already have the days. Okay, after finishing the backward pass, the forward pass, we now go with the backward pass. Okay, the backward pass, again, as said in the previous video, is implemented backwards. So in this case, it should be implemented going up. So forward pass should be implemented first. Of course, why? Because we need to get the maximum earliest finish. In order to compute for the backward pass, we need to get the maximum earliest finish, and we can only get that if we do the forward pass. Okay, so the rules are the following. Rule number 1, the latest finish of the activity which is not a predecessor of any activity is the maximum the earliest finish. Okay, so the activity which is not a predecessor of any activity, so these two activities are not predecessors of the activity, so you cannot find them in the predecessor list. Okay, in that case, if they are not, so the latest finish of both H and G is 41, so that is what it means. Rule number 2, the latest finish of the activity which is a predecessor of any activity is the minimum earliest finish of its successors. Okay, for example, the minimum of the earliest finish of its successor. For example, F has a successor G and H. Okay, the minimum latest finish of this one is the minimum of the latest start of this. So in this case, the minimum of G and H is 36 and 33. The minimum of the two is 33. So the latest finish is the minimum latest start of the successors, okay, of this activity. So in order, and lastly, the latest rule number 3, the latest start of the activity is the latest finish less the activity time. So you already know that the latest start is the latest finish less than activity time days. Okay, so to begin, we need to put in the predecessor list, because in this list we will going to compare if the activity is a predecessor or not. Okay, and the earliest finish, okay, we make also the earliest finish as a list for that matter. Okay, because we need to know the the maximum earliest finish. So if we're going to get this one, we're going to obtain the maximum of this, as I discussed again. So this for loop will gather earliest finish of all tasks and fill the predecessor list of all tasks. So prior to doing the reverse loop or the uh, backward pass, take we need to fill up this to list. Okay, so in order to fill it up, so we make a loop for task in task object. Again, we loop at the objects, the tasks, and then if type of the task predecessor is a string, okay, we make a loop for j in task predecessors, and we create a pattern if it's a to z, and we match the pattern. Okay, this is what you call regular expression, and if we find a match, we append it in j. Okay, we append the j for task predecessor, we append the j. Okay, so it means to say it iterates here. Okay, and then we put this d or e inside. Okay, we get this two upon completion of the iteration. Okay, for example, and then after that we append it as a predecessor j. Okay, so we fill it up. So we fill individually, check if it's a string. Okay, and it is a string. If it's a string, we put it in a list, then we put it in the list, put it in the list. The comma we will not put in the list, we put it in the list, and so on and so forth. Okay, now after that we already append the predecessor list. Now we're going to put in the successor. Okay, the successor list, fill in the successor list for m in task object. If m activity is equal to j, again we check if the activity is equal to j, then the j is the individual task or individual task in the predecessor list. Okay, in the individual task code. So we append it again, the task activity. Okay, and then we append this list, task at earliest finish. Okay, so we type in the predecessor and the successors. Okay, why do we need to have a successor list? Okay, we need to, so that we will know if a certain variable has successor. For example, d has successor, so we know that the backward pass, the successor is very important because we need to get the latest start of the successor. Like for example, again, in order to have f, we need to have the latest start of the successor because g and h succeeds at f. So we need to fill up the successor list also, the successors of each, what you call this, of each task. Now we're going to compute for the forward pass. In the forward pass, we need to put it in reverse again and check if the task activity is not in predecessor list. Okay, if it is not, then the latest finish of that activity is the maximum early finish. Okay, this one is already obtained in the previous loop. Okay, next, if the task activity is in the predecessor list, okay, so we need to make a list again of minimum latest start. Okay, so if it is in the predecessor list, okay, so we're going to get the minimum latest start of this too. Okay, minimum latest start of this too. Now we need to iterate again from the task at successors. Okay, then for that, then we check in the code of the task object if that activity, we mean to say if that the task, that activity is equal to x, so it means that it is inside the successor list. Then we need to append the list of the latest start of this list. I mean to say that if it's there, so we need to append, we need to put it in the list. Okay, then we need to select from it the latest finish is to select the minimum. So after we get the latest start of this, okay, we need to select the minimum, and then we put this at the latest finish. We append it to the task latest finish. Task latest finish is equal to the minimum latest start. Okay, then the common between these two is that we cannot compute the task at latest start, okay, by subtracting the latest finish to the task days, because we already know the latest finish. Okay, in this loop we just need to subtract this to get the latest start. Okay, now to compute the slack, this is a function to compute the slack. So we iterate in the task object, and then we activate the function on each task object. Okay, task that compute that slack, task compute slack. So the task compute slack is here, when we create the task object. So there's a function here to compute the slack. We activate this function, okay, because we already have the latest finish and the earliest finish variable of the object. Okay, that's how it is. This function now, the next function is that we need just to update the data frame. Okay, what this means is that we have the data frame obtained from the Excel file, okay, in the previous function, and then we already have the task objects. Okay, the task objects already have the variables, such as the 4 variables: early start, early finish, latest finish, and latest start. Okay, and then we just need to combine these two. So we make again another data frame, df2. Okay, and this data frame, we do this function pd data frame, and we make it like a dictionary. Okay, so the description, the heading, the column name is description, and we take it from the previous data frame with column name description. We just copy it and put it here, copy it and put the activity again here, and the predecessors again here. Okay, next we also need to copy the days from the data frame into the new data frame, df2, and this one is the result of our computations. The early start is a pd.series of the task at early start. Okay, for task in task object. So we iterate again in the task object, and each task we get the early start variables and put it in a series, and then we name the column as ES. Same is true with EF, LS, and LF. Okay. Afterwards, we obtain also the slack and the critical. Okay. These two, we compute this based on the function of forward pass, and these two backward pass, and this one we compute this based on the function inside the class. Okay, and this one also, is it critical or not? So okay, it's here. Okay, so the critical is already been computed, so we just need to extract it out from the object and put it in a column, and afterwards in a data frame. So this function will return a data frame, complete data frame. Okay, after we've written all the functions that's needed, we now create the final function, which is the main. In this function, this is a step-by-step execution of the program. First, we clear the command line. Okay, dex is that we get the data, read that data, read data. This is the function that we defined before. Next, we create a task object. Afterwards, we compute for the critical path, backward pass, forward slack, and the slack. Next, we update the data frame to include new columns. Okay, final df equals update data frame, df, and a task object. Next, we print final data frame and we save it to a file. We name the file cpm.xlsx. Okay, we print some information, what file we name it, and then we extract the data frame, or we convert save the data frame into an Excel file named cpm.xlsx. And I included here the index equals a false so that there will be no column stating the index. Okay. In order to execute the program, we just need to call in the function main like this. When we call in the function main like this function is executed, and each individual line of this will execute the previous functions that we have already made. Okay, so that's about it. Now we're going to run this program, put in the terminal. Okay, and this file is called, I save it into a folder and call it cpm2.py. Okay, so in the terminal we just write, we are in the same the same directory, so we just type cpm2.py. Okay, now it computes, it obtain the data from the Excel file. Okay, then it runs a program, then it spit out some computations. If we compare this to our Excel document here, okay, so this is our manually computed results, and this is the Python results. As you can see, they are the same. Okay, days are 6, early start is 0, early finish is 6. Okay, late start is 3, late finish is 9, and it already computes the slack 3, and it says if it's critical or not. Okay, and so on and so forth. So that is how we do the automation in Python to compute for the critical path method. Okay, thanks for now. See you again in the next video, and click subscribe if you like this video, and click and put some comments below on what video do you want me to do to show you next time. And that's about it. Thanks you for watching, and bye.